Hello, pre-calculus students. We're ready to go into our second day here of probability. So this is 10.1. We're continuing on with probability, and we're going to learn some more advanced ways of determining probability, which really means just some advanced ways of modeling or counting. Really, all we're doing in probability is we're counting up the number of ways something can happen and dividing it by the total number of ways of occurrences. It's just a matter of coming up with different techniques for securing that. So let's go ahead. Let's take a look at how we're going to do that now. So let's look at this example here. So let's say, for instance, you've got a box of chocolates. And in this box of chocolates, you cannot tell the difference between them. They're all covered in chocolate. But inside, 4 of them have vanilla filling and 8 of them have chocolate filling. And you are asked to select 2 of the chocolates at random. So the first question would be, what is the probability that when you select them, they are both vanilla? So you're going to reach in, you're going to select 2 at random, and what's the probability that they're both vanilla? Well, let's model the situation. So what we're really talking about is the probability of vanilla, 2 vanillas there. So we think about that. Well, what is the number of ways? So we have to think about, we're drawing 2, so we really need to think about drawing each one. So there's 2 separate draws that are happening there. So as we go ahead and we reach in, the probability the first one is vanilla is pretty easy to figure out. Well, there's 4 vanillas, so there's 4 different ways I can get a vanilla, and there's 12 different chocolates total. So the probability of getting a vanilla on the first draw is 4 out of 12. Now notice this is an AND situation, so I am going to multiply because I want to get a vanilla and another vanilla. So I'm going to multiply. Now the probability of getting the second one vanilla, remember, now there's only 3 vanillas to choose from because I've already chosen 1 vanilla and there's only 11 chocolates total, so it would be 3 out of 11. So multiply those up and we get our 1/11th. Nice thing there is that notice we get basically the 4 times 3 is 12, cancels with the 12, and we just get 1 out of 11. So there's a 1 in 11 chance, or we could think of it as being a single fraction if we want to do it that way, and think that it's this is doing the possible combinations of ways we could get a vanilla, and then this is the total number if you want to think of it that way. Just a different way to look at it. All right, so now let's look at the probability that at least 1 is vanilla. So when we think of this, we have at least 1. Now we have to think this could happen a variety of ways. Basically, what could happen is I could draw a vanilla and a chocolate. So I could reach in, pick out a vanilla, and then pick out a chocolate. So let's look at the probabilities of those individually. So this is vanilla and chocolate, so it's still multiplication situation. So what I've got here is I've got a 4 out of 12 chance of picking a vanilla. And assuming I have picked a vanilla, then I would have a 8 out of 11 chance of picking a chocolate. So multiplying that up, reducing, I get 8/33 chance. The other way that I could get at least 1 vanilla would be to draw a chocolate and then a vanilla. So that's chocolate and vanilla right there. So I've got the same basic process. It's 8 out of 12, and then it would be 4 vanillas out of 11 that I'm left to pick. And when I do that, I get 8 out of 33. So notice what I really have now is the way to get at least 1 vanilla is to get 2 vanillas, get a vanilla and a chocolate, or get a chocolate and vanilla. So at least 1 vanilla, I must add up the probability because it could be this, or this, or this. Any of those would get, so the probability of at least 1 vanilla involves adding up those 3 probabilities, and I find out that that is a 19 out of 33 probability. Or another way I could think of it, which is probably actually an easier way to do it, in this case, rather than having to add up the 3, is, okay, what is the only way that I can not get at least 1 vanilla? Well, the only way I can get, a lot of times when you're looking at something, it's easier to think of what's the probability of that not happening, and then subtract from 1. So in this case, the opposite of getting at least 1 vanilla is getting no vanillas. So that would be all chocolate. So the probability of all chocolate would be chocolate and chocolate, which would be 8 out of 12. And then when you went to make your second draw, you'd have one fewer chocolate, you'd be down to 7, and you'd have one fewer total candy. So if I go ahead and figure this out and reduce it down there, I get 14 out of 33. But notice, if I take 1 minus that, because remember, the total probability is 1, so I would get my 19 out of 33. Sometimes that's a lot faster way to do it. All right, let's go ahead and let's look at another method of calculating probability, and that's using Venn diagrams. Venn diagrams are a great thing to do whenever you've got overlapping categories. You know percentages of things and you know overlapping categories. So let's look at this example here. So we have in a high school, we're told 54% of the students are girls. We are also told that 62% of the students play sports. And finally, we are told that 50% of the girls play sports. So here we have we know percentages, and we know a lot of overlapping categories. So we've got girls, some of them are playing sports. We have students, some of them are playing sports. And so we've got all these different overlapping categories here. So what we want to do is set up a Venn diagram. And what we want to do is look at the two main things that were talked about here are playing sports and girls. And notice that here is our overlap here. So if I think about this one, the key is how to set up the Venn diagram. And so what we want to do is we want to set up a circle that would be a circle for girls and a circle for playing sports, and then make the corresponding overlap be correct. So what I'm going to do here, and I will actually go ahead and I'll sketch this on a separate sheet of paper so you can see how, I'll reveal it for you here in a second, but so you can see how I would actually build this. I think it'll probably be easier if I just go ahead and show you a sketch of it. So if I'm here, and what I would do is I would set up a box, and then I would go ahead and do overlapping circles for my Venn diagram like this. And notice what I would have to look at here. I would look at this and I would say, okay, I've got, let me slide this up so you can see a little better there. So I know that this circle here is going to be girls. This one here is going to be sports. And I know that this total box is all students, basically. So this entire box here is students. So what I see is that 54% of the students are girls. So this circle here must contain 54%. But half of them are also in this sports circle. So I need to divide my 54 evenly between this and this. So that would be 0.27 here and 0.27 there. And I also know that 62% of the students play sports. Well, that means that this total circle here has to be 62% or 0.62. And if 0.27 are in there, then that leaves 0.35 right there for that to add up to 0.62. But now this whole amount must add up to 100%. So notice if I look here, I've got 0.27, 0.27, that's 0.54. This is 0.35. If I add that up, I get, what do I have, 0.54, so it looks like I got 0.89. So that leaves me with 11% that are outside of those circles, because all the separate categories here have to add up to 1. So that will be my Venn diagram. So now I'll go ahead and show it to you. Here's my constructed Venn diagram. So it looks like that. So now I can use this to answer questions. So this is a model of the situation. Now I can answer questions. So here's the question, first one. What percent of boys don't play sports? So in order to do that, what I have to do, remember, percentage of boys don't play sports. So the total category is boys, and the numerator has to be boys that don't play sports. So what I see here is that I've got 0.27 here. Girls are not in the playing sports category, but for the boys to be there, that's this 11 right here. So I could put 0.11, and of the boys don't play sports. Notice girls are 0.54 total, so boys total would be 0.46. So I've got 11 out of 4. Now I can call it 0.11 over 0.46, but I just multiply both by 100 to get rid of the decimals anyway. And so we're talking about 11 out of 46. And we can give that as a percentage if we want to. It's 23.9% of the boys don't play sports. Now, part B says, what percentage of the students who play sports are boys? So notice here, now we're looking at the total package here of students who play sports, and I want to know the target is our boys. Well, my total target for sports, see, are 62, and the boys are the 0.35 of it, because see, they're not in the circle of the girls. 0.27 are in the girls' circle, 0.35 they would be boys. So I'm going to divide the 0.35 over the 0.62, or 35 over 62. Doesn't reduce, so I get as a percentage that 56.45%. Now moving on, I keep wanting to move on, but I want to leave my Venn diagram in view. Oh, I guess we're not going to answer any more about the Venn diagram. We are going to move on. Moving on to conditional probability. So conditional probability is a situation where we've got probabilities and one event depends on the other. So it changes based on what's already happened. So here's our formula. We're talking about the probability of B given that A occurs. And notice here, I've used B here and A here because we're talking about A is the thing that's happened first, and we want to know what the probability of B is. So we know that A has occurred, and we want to know what B happened to be. So the way that we draw this here is this is the probability of both A and B happening, divided by the probability of A, that thing that we already know has occurred. So let's look at how we handle conditional probability. So here's an interesting situation. We have two cookie jars, and we cannot see into the cookie jars. So these are maybe up high. We have to reach in and grab. This cookie jar has 2 chocolate chip cookies and 2 peanut butter cookies. And this cookie jar has 1 chocolate chip. And of course, we really hope we draw from this one because peanut butter cookies are evil and we don't want to eat those. But this is what it looks like right here. So here's the question. If you draw a chocolate chip cookie, what is the probability that it came from jar number 1? So I reached in and I drew out a cookie. Didn't see which jar. I didn't know jar 1 or jar 2. I didn't know which jar was 1, which jar was 2. I didn't know which one had the different ones. And I pull out a chocolate chip cookie. Well, obviously, it could have come from jar 1. It had chocolate chip cookies, and it could have come from jar 2. The question is, what is the probability that it actually did come from jar number 1? And I want to be able to calculate that. Now, obviously, if I pulled out a peanut butter cookie and I asked what's the percentage that it came from jar 1, you'd tell me it's 100% because there are no peanut butter cookies in jar 2. If I ask you what's the chance it came from jar 2, you'd tell me it was 0 because there's none there. But this is a little bit more challenging when we drew a chocolate chip. So let's model our situation. So we're asking the probability that it's from jar 1, and the given thing that has happened is it's chocolate chip. So we already know that's happened. So first I have to look at the probability of it being jar 1 and chocolate chip. So one way to do that is, probably a good way to do that would be a tree diagram. So if you wanted to, you could set up a tree diagram to figure out probability of jar 1 and chocolate chip. I could show you a tree diagram on how to do that. So for instance, we would have a 50-50 choice of being jar 1 or being jar 2. And then if we pick jar 1, we know we've got 4 possibilities. Well, I guess we know that we really have 2 possibilities, chocolate chip or peanut butter. So I'll just do it with two possibilities. We have a 0.5 chance of going chocolate chip and a 0.5 chance of going peanut butter. And if we pick jar 2, we only have, it's a simple 1 chance of picking chocolate chip. There's no other option at that point there. So we want to know what is the probability of it being jar 1 and chocolate chip. Well, that's following this branch here. So we know that is going to be a 0.5 times 0.5 chance, or a 0.25 chance of being jar 1 and chocolate chip. So when I set that up, that's going to be that 0.5 times 0.5. And the probability of it being chocolate chip, notice now, the way to be a chocolate chip, it could either go this way, which would be 0.25, or it could go this way, which would be 0.5. So the probability there of those being either or would be 0.75. So looking at that, I see that my probability there, when I reduce that down, is 1/3. So it is a 1/3 probability that it came from jar 1 if I already have a peanut butter cookie. Okay, homework. Homework is 10.1. It is 27 through 41, and then 45 through 50, all of them. So go ahead and work those probabilities and hope things go well, and I'll see those of you that joined me on Zoom today in a little bit. Sorry things were so late getting started this morning. I was spending a bunch of time grading. I had a bunch of late assignments turned in that I had to grade. So hope things are going well, and we'll have another video for you tomorrow.